Okay, now I hope my screen is visible. So yes, so I thought maybe in starting I started thinking maybe because of all of you know week 1 to 4 just extension of whatever we studied till week 4. That's why people are not joining. But maybe because of one not getting the message, uh, all of you able to reach calendar, right? All of you.
Yes, sir, but
Yes, sir.
um, from a while, I guess, even I was receiving this notification about the live sessions. Earlier, I
Mm.
used to receive mails and sometimes on WhatsApp as well, but now we don't. Maybe that's one of the reason.
Okay.
That's the reason I had messaged you that do we have a session today.
Okay, well now we'll try to keep on, updating on G Space also. I used to be there generally. I'll try to be on there. And also if no needed, I don't want any session. So in that case, we'll keep one session a week and on-demand session from the next term maybe or upcoming weeks also. We'll try to keep one session and on-demand session also. If I will ask even that if you need it, then we will keep on Tuesday timing as a on-demand and Friday will be the same as for for a week session. So Tuesday will keep like this. So Tuesday session. So this could be there. I'm not giving COT. It's depend on the availability of the student. If student are coming on Tuesday, that would be good. So okay, that's enough giving the information. Okay, doubt should be the main priority. So first thing is that and also one thing I missed that regarding the graded errors. If you are getting error like this in G space, I got one error also. And also one last session somebody has mentioned to Vishal that okay there is an error. Okay, so that I was missing to do sign off or the to give the correct marks to all students. We needed at least to know where is the wrongness in the graded assignment. So now I hope all of you can post there at the sudden moment, like once the due date is over. Once the due date on the next, after 1 minute or in the whole day, even next day, you can post that I'm getting this error so that I can correct. I'll try to correct and try to give the possible marks, whatever would be there. So that is main important for me also to create this G space. Okay, so let's be on the track to doubts. So what are the doubts? Yeah, Vishal, you have something.
It was from week 6, sir.
Okay.
Just a minute. Let me. Uh, Week 6, the content which was being taught at the end. Just a minute. Yeah, this circular convolution and circular matrix.
Okay.
Uh,
Where is that?
at the Not here, sir. The
Circular.
very last lecture.
Yeah, here is convolution, circular,
Yeah,
convolution and circular
matrix.
matrix.
Yeah.
So what is your doubt there?
I did not understand this part only, sir. It was really confusing. Yeah.
Okay. Okay. The convolution is, this is here. It's already mentioning that this kind of, representation we'll call as a convolution. Like here, this yn. This is a, this circulation. This convolution is a kind of, uh, linear transformation. See, if you see it, these are the, this x1, x2 till, uh, these are all, this these are the variables you have, and h0, h1, h2 until hn, yeah, or it will go along. It is, it is your coefficients. Okay. Okay, for example, it is a kind of, see here it is. See how it is written. If you multiply, just multiply this matrix you have, and if you multiply, you will get this one. So it is, let me write it here. So let me make it a go. Screenshot first. So see it how it is. Suppose we have, a kind of this one, like, uh, you know, suppose this is here at, let me change the color here. As here, see it, if you have like writing to be, the whole thing is, whole thing could be written as like this, as we have this one, this, the linear transformation, no? So here, if you remember that we generally write, see, this is x2, x3, x4. These are the variable we have, and the expression could be written, in the form of, uh, one dimensional. So this is one thing, that this is a linear transformation from n variable to r1. First, we have to remember this.
From
This
any dimension to a singular dimension. So is it like that?
Yes, yes, from fixed dimension to one dimension means r. If you see it here, this is, written in the form of this here. And whatever using, so right, we can convert that, matrix, sorry, we can convert a linear transformation in a matrix form. So as, if you see, if you multiply this matrix to this vector, what you will get? A vector, right? Sorry, yeah, if you multiply this, you will get a scalar. This is what it is, no? If you have, let me write here, suppose this is 3, 4, and 2, 1. If you're multiplying with, 1, 2, what you will get here? This will be multiplied. Okay, just a second. No, no, no. I'm just missing something. The circular matrix, a kind of linear transform here it is, but here the coefficient. So here we are, see, this is this convolution, this form. This form is written in the form of this matrix format. That's all. If you know the circular matrix. So if I'm writing here a vector, let's say this vector, uh, let's say 1, 2, 3, 4, or in the vertical form I'm writing 1, 2, 3, 4. This is a, and I'm generating, a circular matrix using this vector. So how I will write this? So see it is as here, this one. It is, just a second, sorry, just a second. Once it is, this is what I am thinking here. It is a different. See, this is the one circular matrix. As we have studied this, I know, just a second, let me confirm as professor is teaching.
Excuse me, sir.
Sorry.
Um, can you teach? Can you give an example? Instead of since sir is using variables, can you use the actual numbers so to give the examples to
Yes,
solve an
yes,
example?
yes, 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 yes,
Maybe that will help us.
yes, yes. Just a second, just a second, just a second. See this Carnula sensor. Let me now start. So this, so see this. What is happening here? See, this is just a, relation, a linear transformation here, but it is, ideally it is generating a circular matrix. So this linear transformation is as written here. So see, this is started from, so see, this is an idea sir is expressing it here, how to convince with what is a circular matrix. But exactly what is circular matrix is writing, if you have, suppose I'm writing like this, suppose 1 2 3 4, okay, then the next row, so the next column is going to be only using these entries. The next column is going to be here, h4, this one here. So here is, let's say this is here, h0, this is h1, this is h2, h3. So if this h3 is going to be here, and now it started, from again this h1, then h2 means here it is going to be 1, and then this is 2, and this is 3. Now again going to be circulate. So here it is going to be 3 and then next 4, right? So this is going to be 3 and then it is going to be 4 and then 1 and then 2. If you see it, it is circulating here as this one.
Yes, sir. But
Hmm.
um, why are we using it? And for how long are we supposed to do it? Because if we circulate it one more time, then the diagonal will become one. That is, the all the diagonals will become same. But what is the reason, or which type of questions can we expect on such topics? That's what I'm trying to ask.
On this topic, it's great at given the idea, if you have, or in the activity have given idea, just if you have a circular matrix, what are the going to be eigenvalues? What are the eigenvectors? See, it have a specific property, for the eigenvalues and eigenvectors. So eigenvectors are going to be, fix the first eigenvector even 1 1 1 1, and some 1 upon root of something is there, right? And
Yeah.
the eigenvalues is some specific, you know the root of, just do the root of how, if you just count the how long, which like mean to say, like this is from R4, means the matrix of, R cross 4 cross 4, if you generate this convolution. So that means we have to find the, fourth root of unity and then generate the eigenvalues and eigenvector. So it is, here what it means. So if you are generating the columns using one, if you have given one column, we are able to generate the all others column. Similarly, we can get the eigenvalues and eigenvector. It could be kind of generate, we are easily can generate. And not only that, if you see there, the columns are, no, so I sorry, eigenvectors are, same for all, even whatever the entries you will give, only the, multiplied form here. If you see the eigenvalues and eigenvector of this form, this is 111, and the next is, 1 root omega of, this w8k, or omega generally called, we call it as omega also. And eigenvalues, these are going to be eigenvalues and these are the eigenvectors. Okay, so more explicit form is, see sir is started with an example that, okay, suppose this is the, you have, if you have one row is given, you can generate the all matrix. Okay, once we generate the all matrix, then eigenvalues now we can start generating, you know this here, e power. The eigenvalues is going to be this one. No, so eigenvalues are this. What are the formula to write the eigenvalues? This is here, no, this one. Eigenvalues could be here.
What are these HJW from 8 to 0 raised to J?
Okay, what are these? No,
Yeah,
this, see this is what is w8, e power I2 pi by 8, right?
yes, sir.
What is w? Similarly, what is this is w8, no? So this and this w power k is now going to change. So here the vector is okay. So let me take a picture of it. So here main idea is, what is a circular matrix and what are the going to be eigenvalues and eigenvector. How the circular matrix came, that idea is given as in the convolution form. You know how we are generating. Okay, that is just an idea, just giving. So this is a specific, convolution, a specific type of series explaining that how we, like how we are, what a specific type mean to say. Let me. Uh, So that how this convolution, sorry, this circular matrix is generated, that we need a background. So that is your convolution. But the main idea is what is the circular matrix and what are going to be the eigenvalues for that and what are the eigenvectors. That is the main only thing. So generally the question would be like this. Suppose this is the vector is given, the first column is given, okay, or a vector is given, generate the circular matrix. That is the problem. So here, if it is the first column, then rest all could be easily generated. You have to know that how the circulation is going on. If you see it, if is here the 7, then this is the 7, then it started from here, h0, h1, h2 till h6. Similarly, now next is 6 and then 7 started from h5. This is how the whole matrix going to be generated for a circular matrix. Somebody's want to say something. Okay.
Oh, somebody had reacted, sir. So that's the reason I asked.
Okay. Okay. So
Sir, can we expect
are you
push?
able to get the circular matrix at least? What is a circular matrix? Convolution is just an idea how we are getting this circular matrix. That's all. If you're not able to understand, you can even skip because that is an example. Sir is explaining an example, but the main idea is what is a circular matrix. Okay,
Okay, sir.
what is a circular matrix, one thing. And now next is what is going to be eigenvalues and what are going to be the eigenvectors. So what is the eigenvalue here is this one here. This is the main formula here. For a given eigenvector, this one, the eigenvalue is going to be this here. Okay, this is the main formula. This is the here. V is an 1 alpha, alpha square. If it is, we have till, 1 to 4, 4 cross 4. So this is going to be alpha cube. That's all. That's all it is going to be. Yes. 1 alpha, alpha square and alpha cube. This is still same. Yes, it is fine. So yes, this is so this till alpha cube as it is, h0, h1, h2, and h3. This is how it is going to be. And what is the alpha? Alpha is here it is written here. This is W8. Okay, W8 to the power k. Here it is. For each time it is going to be this one. So what is a W now? W is okay. Where is that? W is going to be this. W is going to be here W8. The main thing is W8. The main representation here K is going to be K is equal to 0, 1, 2 till 3. It is going to be. So here W8. So here it is in the case of our case. This is going to be W4. Okay, because our we have this 4 cross 4s. This 4 cross 4s. This is going to be W4. And what is a W4? W4 is e power I 2 pi by 4. Here it is, see that here it is of 8 case, then it is going to be our case. This is 4. And now once we know the W, this W4, now we can generate alpha. Alpha is going to be, each time now it is going to be change. So this is
So can we
just
expect
a second.
questions related to this topic in quiz?
Yeah, at least probably one question from here. This is one question from here at least. Okay.
One
So
question from circular combination.
yes, and let me write here alpha. Alpha is here this one. Alpha is so W we know. Now alpha is going to be change each time. Okay, just a second. Where is that alpha? Here, somewhere. Okay, let's just a second. As here, sir is as here itself. Whatever I am taking the question, same here, sir is also explaining. See, this is alpha here. Okay, this is alpha here. This one. What is here alpha? Alpha kw8 the power k. Okay, each time it be generated, eigenvalue is going to be okay multiplied here. Just a second. It is just a formula, no? This time also I am just looking. I'll confirm it once. Okay, so if you have this circular matrix, suppose 4 cross 4. Okay, so eigenvalue is going to be using first we will find the you know this w8 w8 means here for 4 w4 which is e power I 2 pi by 4. Now once we find w4, then alpha, here alpha is going to be here. Why it is sorry, is also making, just a second. See, this is a simple way. What is the way to, if you have a given matrix, right, 1 minus lambda I, this is, this is the entry. Like suppose you have a matrix, so a minus lambda I, that's how we use to find, right, the eigenvalues. That is the one way. Okay, am I audible? Okay.
Yes, sir.
Yes, sir.
That is the one way, but we have one formula which is written here. So that's why if you are confusing with the alpha and w4 w8 w4, that is just a formula. Without doing this we can get the eigenvalues and eigenvectors. That's all. That's the meaning here. But here I am just missing that this twicely written. Sometimes alpha is this one, and this here alpha is this w8 to the power 0. I'm just missing that. Where is the wrongness? Anyone can help? Anyone have seen this? Okay, this alpha, this one. Okay, for each alpha, this could be created. So suppose this is alpha here, w8 to the power 0. So by this way, the eigenvector is going to be w8 0, w8 0 1, w8 0 till 4 we want. So here is the 8 is there. So okay, 4 is, this one is 4, this is 4. This is called omega sometimes. So this is still here 3. Now next, the eigenvalue is corresponding to this is, here the formula is h0 h0 plus h1 alpha to the power minus 1 plus h2 alpha to the power minus 2 plus h3 alpha to the power minus 3. This is the first eigenvalue. Corresponding to this eigenvector is this one. So here, okay, so now next alpha is going to be the w is alpha is equal to w8 to the power 1. Now the eigenvalue, the corresponding eigenvalue is going to be h0. This is plus h1 alpha minus 1 plus till h3 alpha minus 3. So if, so each time, so here is now I think I'm now I'm correct. So what is the way if you have a circular matrix? Okay, suppose this is, we have 4 cross 4. So what we will do, first we find what the, that is called the fourth root of unity. No, fourth root of unity, even we can uh, generate each time. So here is, uh, now let me write here. So first we found the eighth root of unity. So that is, called omega w8, or so here, sorry, w4, which is going to be e power I 2 pi by 4. Now once we have this, now eigenvalue is going to be, eigenvalue is here going to be uh, the formula, which is, alpha. We'll write here alpha, which is nothing but w4 power 0 here, which is going to be 1. If it is this, then eigenvalue is going to be h0 plus h1 alpha to the power minus 1 plus h2 alpha to the power minus 2 plus h3 alpha to the power minus 3. This is the first eigenvalue, let's say lambda 1. And corresponding eigenvector is going to be v1, which is 1. Okay, and uh, this is, here it is alpha 1, this one, alpha alpha square alpha q. This is, now next is again lambda 2. So we'll again first, again in this case, so here let me write the k alpha k, it should be here alpha 0. And if it is the mixing case, then next what is the going to be alpha? So here is, next is alpha is going to be w here to the power 1. And now eigenvalue, which is lambda 2, lambda 2 is going to be again h0 plus h1 alpha. Here now we'll use this alpha to the power minus 1, h2 alpha to the power minus 2 plus h3 alpha to the power minus 3. And corresponding eigenvector is going to be again using the same formula. Here this one, this is going to be, which is nothing but e to the power I 2 pi 4. So here in this case it is going to be 1, as e to the power I 2 pi by here 4 to the power 0 is going to be 1. Here is, it is going to be this one. And now our h0 is 1 2 3 4 we have. So here is what, 1 2 3 4, which is here h0 h1 h2 h3. So each time we'll keep here the values, and alpha to the power we can each time, right? So this is alpha to the power minus 1 is going to be e power minus I 2 pi by 4. Similarly, we can generate all others and we'll add them, we'll get the eigenvalue. And here the eigenvectors is each time we can generate using the same alpha here, this one. So this is without doing this a minus lambda I. If you don't want to do this, we can even generate the eigenvalues by this formula as here written. Or otherwise a minus lambda I we can do and find the eigenvalues. That is another way. Without doing a minus lambda I, we can do this by this way. I think Vishal have left. I don't know. Okay. Is this clear first?
Yes, sir.
If not, please let me know. Again, I will discuss that. I why I'm missing. I didn't see even this one also, but now I started looking, so that's why uh, I just missed that. I took time to understand also. But this is the way, this is the main idea, is that if you have given a circular matrix, if you do one or two problem, you will easily get that how to find the eigenvalue and eigenvector. Why this is Circular matrix is we are here because generally the circular matrix given more than 4 to 5. The circular matrix is going to be 4 to 5, 5 press 5 maybe. But without knowing the whole entries, if you know the first column only, we can generate even know all eigenvalues and eigenvectors. That's the main here idea. And the use of circular matrix is even here sir is explaining that how we are generating what is the circular matrix. So here some inputs are there, here some filters that you know in terms of once you do the you do ahead courses you will see it or already have seen also this what is happening here. And what, see these are the coefficients. You have some input, it is multiplied and you are getting outputs. That is what it is happening here. And this is the main idea that suppose this is you have or maybe this thing is happening, this could be converted or think as a circular matrix. That is what it is. This is just is an example. Okay, this convolution is just an example. The main idea is that this system could be think as a circular matrix. Okay. So no, there the entries are 0 and 0 is another H0, H1, H3. Here is sir is now saying that we can extend even here not only H0, H1, H2, H3. Maybe the coefficients could be till whatever the order. So that's why in the more general form, the circular matrix is this one. This is the circular matrix. It may have more orders. So without doing the uh, a minus lambda I to find the eigenvalue eigenvector, we can do by this formula with one root of unity. One root of unity is called one root of unity. So here how it is generated, this is called omega, but here is sir is writing w. I think in pronunciation sir is maybe saying omega. And what is happening here? How we'll generate each time we have to find the alpha, and using that we have to find the eigenvalue, and this will the corresponding eigenvector. The formula is here. This one. This is here. And eigenvalue formula is this is here h0 h1 h2. Will multiply it. So can we anybody can tell the similarity between the so okay one question would be suppose I am just changing I'm not changing the order, I'm changing the entries. So, what is the effect on eigenvalues, eigenvector? Anyone can answer here. Eigenvalues are going
Eigenvectors
to
will
be
be the
changed or
same.
eigenvectors? Sorry,
Eigenvectors will be the same.
eigenvectors are going to be the same. Only the eigenvalue is going to be changed. Even in that case, only the coefficient will multiply it there, h0, h1. Otherwise, if you say the root of unity, that is going to be the same for each time. So eigenvectors are going to be same. So this could be a question. Even I'm not saying, but can be asked also. A different two columns would be given and said that in option wise, both matrices have the same eigenvectors. This could be one question. So this is the property of circular matrix. Okay. Any other doubt, anyone? Vishal have left. I think he's not. Whatever I was saying, he didn't get that. I don't. Okay. So Prithvi, Pawan, Dhruv, Manoj.
Yes, sir. I have a doubt in week 7 graded assignment in
Okay.
question number 8.
Week 7 graded assignment. Due date is over for that.
Pass. Yeah, already pass.
Okay. What is your doubt there?
Sir, I'm not able to understand the how to solve the question. And
Which?
also question number 8.
Okay.
Yeah. If possible, please can you explain also the concept behind this question?
Okay. So what is happening here? Suppose the subspace is given this one. Let A be the projection vector obtained by projecting this vector onto the subspace this. Find the value of ABC. So what is happening here? Suppose this, this is a plane. If you remember, this is a plane passing through origin. Not remember. Are you getting it? So what is
Yes, sir.
happening here? Suppose this is a space. Okay, this is the space. Okay, in pictorial form, and I want to project. So suppose here is a vector. Okay, suppose this is a vector 1, 0, 1. This is the vector you have. I want to project this vector here. Okay, on the subspace. That is what it is. No, I want to project this vector on here in space. Yes. So what is going to be this? Once I have projected here. What is going to be that vector once I projected here? This is the question. So if you want to do this problem, how we will do? We just do the projection formula. If you remember the projection formula, suppose for example, okay, so this is a space, no, this is a space. Suppose I have a vector this A here. Okay, I want to project this vector A on this vector B. Suppose I want to project, okay, maybe here. So suppose this, I want to project this vector A on this vector A on this vector B. So what is the formula to project? If you remember, how we'll get this? How we'll do this projection? Do you have any idea? Projection is, I am just giving, you can remember even always. So what is that projection? Suppose I want to project this vector A on B. So what we will do, just do the dot product between A and B.
Inner product. Okay.
Yeah, inner product or dot product. Sorry, inner product is the best word. So inner product, just do the inner product and multiply with the vector B, divide with the norm B where you are projecting.
Okay.
So okay, I want to project A on B. Okay, A on B, so dot product with A and B and direction B. Yes, that is what it is.
Okay.
That is what it is. So what is, so if it is, this is only on single vector, no? Suppose here another vector is there. Okay, so here is another vector. So another vector mean to say, uh, suppose you are a space, no? Suppose you are a space here as here this one. This is the space here. Okay, this space here. This space here. How many basis vector in this subspace? Means what is the dimension for this subspace? What is the dimension of this subspace?
3.
2, right?
Two. Yeah.
This is a two-dimensional subspace. Means if I want to project this vector on this S, so this S is not only in this space. This is not generated by only a vector A. This is needed another vector B, correct? Two vectors needed
Yeah.
to generate whole space. So mean to say, I want to get this projection on here, means I have to separately project on A and separately project on B. So so the idea, let me relate it here. Suppose another vector C is here. I want to, so here, please distinguish the word here. No, okay. Suppose this is A here. So let's say this is C, B and C is the same thing. So okay, suppose another vector is C here. So I want to project on both. So what we will do, I will add the same projection. So project again on C and add them. This is the final projection. If it is, suppose I am projecting on separately. Means separately means on both simultaneously, means then project separately and then add them. That is
Okay.
what. So here is this subspace needed two vectors as here B and C. So first find that vector, means find the basis element. Okay, first find the basis element. And not only the basis element, if you see the projection, means basis element those vector which are orthogonal also.
Gunnar.
We have to find that two vectors here, this one and this one, which are orthogonal. If you are not able to find, just do the Gram-Smith. That is what we usually do, right? So for example, let me take suppose a basis element here. So x minus y, this is plus z, this is equal to 0. That means here x is equal to y minus z. Means one vector is going to be, if you assume z is equal to 1 and y is equal to 0, so x will be 1 0 1. This is one vector, and another vector is 0 1 1, right? If you assume yz is equal to 0 and y is equal to 1, so that means these are the basis, these two are basis element of this subspace. That is the way to find the basis element also. Okay, if you whatever I am doing, that is you can follow, that way you can follow.
Okay.
So these two are actually, if you check, these two vector actually will satisfy this equation. That's why I'm also, see, I am generating by this from this equation. So these two are actually basis element. This is the process to find also. This is a way, not process, this is a way. And check that is these two are orthogonal. No, correct?
No.
These two are not orthogonal. So
Yeah.
we have to find the orthogonal and then do the projection separately. That is what it is happening. So either do the Gram-Smith on these two and find, or by a trick method or think in your mind, choose such a way that these two are independent. Sorry, these two are become orthogonal. How I will choose? So to choose, if you multiply directly here, this is 0, this is 0, but this give 1, right? If you do the dot product.
Yes.
How I will do then?
Yes, sir.
Uh, so let's do one way, that let's take half, maybe that would work. Maybe so that's the way. If you want to do Gram-Smith, we can do Gram-Smith to find the orthonormal, or otherwise we have to think here how I will choose to satisfy this equation and also become the orthonormal. How I will choose here. So to choose, one way is that if you choose x is equal to 1 by 2 and z is equal to 1 by 2 and y is equal to minus 1. Correct? So this is what, 1 by 2 and minus 1 and 1 by 2. And next is maybe uh, minus 1 by 2 and 1 and minus 1 by 2. Or both are same? Okay, these two are same. Okay. How I will choose here? Okay. I think we have to do Gram-Smith then. Okay. To find the orthonormal. Okay. Otherwise, any other way? Are you able to tell me a vector which is satisfying this equation and also orthonormal to each other? At least orthogonal, we can change in orthonormal. Or maybe this one. Minus 1 is there, 1 by 2 and 1 by 2. No, no. Okay, minus 1 and minus 1. Okay, minus 1 and minus 1, and this is plus. Okay, this is the same, I think, no? This is 1 by 2, this is 1 by 2. Minus 1, and this is plus here, 1. And now if you choose, this will be minus 1 by 4. This is 1 by 2, and this is 1. I think this would work. This is minus 1 by 4 plus, and this is minus 1 by 2, and this is minus 1 by 2. No, this is 1 by 2, just 1 by 2. Okay, not working. So let's do a gram Smith, otherwise I'm not getting it directly. So what is the way to get this? So assuming to be this is the U, okay, and now sorry U1. So U1 is going to be this one, 101, and divided with the norm root 2. Next thing U2 is going to be what? Uh, 0, 1, 1 subtracted by what? Inner product you will take between 101 and 011, and outside what? Outside the 101. If you remember 101, if you remember the inner that divided by root 2. If you remember, I want to do gram speed between three vector v1, v2, and v3. So what is that? U1 is going to be your v1 divided by the norm of v1. U2 is going to be v2 minus inner product between u1 and uh, u1 and u1 and v2, and outside u1. That is what I am writing here. So this is 0, 1, 1 minus inner product between them is 1 only. We are getting 1. So this is 1, this is 1 here, this is 1 upon root 2, 1, 0, 1. And here I am dividing with the, here norm divided by norm square, no? This will be 1 by 2 only. Divided by the norm square. Here is also v1. Sorry, u1. Just remember that this is going to be 1 by 2. So this is 1 by 2. So this is going to be minus 1 by 2, and this is going to be 1, and this is going to be 1 by 2. This is what it is. Minus 1 by 2, 1, and 1 by 2. So will this work? So here 1 is 101. 1 is 101 divided by the norm, and another one is. Are you getting my idea what I'm doing? I'm
Yes, sir.
not.
Yes.
I'm just.
I'm also solve this question the way you solve. I'm also
Yes.
solve same way.
Yes. Yes. And once we get this vector, now do the separately projection and add them. Maybe I'm doing wrongness in the calculation. I don't know even, but the idea is this one only.
Okay.
So maybe let me show you the solution if I'm making wrongness. So let me show you the solution here to go. We want to move ahead. So let me show you the solution. And the solution have posted. No, I think no. Okay, I will see too. Where is that? Okay, this one here. See what is the happening here? Orthogonalization. He found this, and orthogonalization. Once he found the orthogonalization. Once he did the orthogonalization, see same. I got this vector. I think the same. This one and this is the same here. These two. And now once we do the orthogonalization, now the projection is separately do the projection as here this one, and separately closest point. Oh no, this is the closest point. Objective. Okay, sorry, this one is here. This 110 1 and 011, he got this one. Okay, this one, these two vector he got. I just do the Gram-Schmidt process here, he did. Okay, Gram-Schmidt process he did, and then finally projections he did. Projections on of projection of this vector is going to be, see this is the separately done here, this one and this one. So even let me give the link, even you can also open, okay, so that you can see in the detail. Okay, and I will give to the upstream to upload also. Okay.
Okay, sir.
Yes. Yeah, hello Vishal, you left. I don't know. Did you get that? What is a circular matrix?
Actually, there was this power cut in my area side, so that's the reason.
Okay. Okay.
I'll watch the recording if needed, sir.
Okay.
Yeah.
So I will tell you the basic idea. I'm just let me finish the basic idea. What is a circular matrix? So the convolution is just an idea to understand what is a circular matrix. Okay. And once we know the circular matrix is, if you have a given vector, this one, or maybe first column is given, using that you can generate the whole matrix. Now once you generate the whole matrix, okay, once we generate the whole matrix, this is the matrix you have. You can follow m minus lambda I to find the eigenvalue. This is one way, usual way you have, okay. But without this, we can get the eigenvalue and eigenvector. And what is eigenvalue and eigenvector each time? So that is, okay. So suppose we have the order of the convolution matrix is 5 cross 5. Okay. So what we will find? We'll find the ith root of fifth root of 1. Means that is called the fifth root of 1. That is omega also called. Okay. And it is nothing but e power, no, here I 2 pi, here 5 is going to be w. Here is we are writing here w5. Now each time we'll generate alpha using this w. Okay, using this w will generate alpha, which is nothing but if we, so if I'm writing here alpha, means here it is going to be, alpha is going to be here w5, w5. Okay, this is w5. So suppose this is the first alpha. Using this first alpha, lambda, which is eigenvalue, is going to be h0 plus h1 alpha minus 1. What is the h1 h2? Here the entries h0 h1 h2 till h5. This, by this way you will write here h5 alpha to the power h4 here, what is the power minus 4, and the corresponding eigenvector, which is, I'm writing v1, is going to be 1 alpha, okay, alpha square till alpha to the power 4. Okay, this is the first eigenvector. The next is going to be, you will again generate alpha, which is going to be w5, what, here 1. Using that, lambda eigenvalue is going to be h0 now. Again this alpha, h1 alpha, this alpha you will use here, alpha to the minus 1 till h n. So by this way you can generate the eigenvalues, or if you do able to by this way, you can do, and each time you can generate. So this is a easy way. Without knowing the all entries, we can even generate the eigen values and eigenvector. That is your circular matrix. So what is the thing is that if you do one or two problem, you will get the whole idea. Just do the problems, you will get the idea that how to find. If you are already in the graded problem, it is given the formulas, and also if you just watch the process also, we can do. This is a bit calculative, but maybe you can understand while looking the solutions of graded and practice ones. That is what it is happening.
Okay, sir.
Okay.
Yeah. After trying a few examples, if I encounter any problems, I'll ping you on the in the G space.
G space, sure, so we can discuss even there also.
Yeah, yes, sir.
Okay.
And sir, can you please list the steps which we have to follow during the Gram-Schmidt orthonormalization?
Steps.
Yeah, because it becomes really confusing. First we find the norm, uh, and then we name it as u1 or some other variable.
Actually, there is a way. Actually, the thing is that suppose I'm writing here. Suppose I want to normalize. Sorry, yeah, I want to normalize these three vectors: v1, v2, v3. Okay.
Yes.
The process is simply take this first one, okay, assume this first one is u1 but slightly change v1, divide with the norm of v1. That's all. This is your first normalized vector. Okay. Now next is what? I am writing u2. U2 is nothing but take this v2. Okay. V2. Okay. To see the difference, my difference also. V is writing like this and u am writing like this. Okay. So v2 minus. From v2 subtract. What you will subtract? Inner product between where? Between v2 and this generated u1. Okay, v2 and generated u1, and then after uh, subtract here also this out. This is a scalar, and now this vector. So what is the idea here? No, idea is happening. Suppose you have a vector is given, let's say, uh, e- okay, what is happening? Suppose your vector is given v1. Let me show in the pictorial form, then you can easily remember even. And here suppose v2, and here suppose v3 is given. So what is happening doing while doing the Gram Smith? Once I am finding this first vector u1, I am just dividing by the norm of it. Okay, I am just dividing by the norm of. Next is what is happening from now. Next is I am finding u2. So from this u2, I will try to remove that coordinate which will not lie in this. That is what it is happening. If you see, I want to remove, I am trying to remove, I want to remove that part which is not going to lie here, v2. See, that is what subtraction and then multiplied u1. That is what is happening. That is the main idea. So in pictorial form it is, in pictorial form it is, if I form it, no, it is in Gilbert Stein, it more accurate picture is given. Or even are you able to understand or not? I am saying you are removing that part from v2 which will not, which is lying actually in v1, sorry, here v1, or this after normalizing it, I'm trying to remove that part from v2 which is actually lying in this part. So those try to remove from this. Suppose here is alpha, here is beta. So here is also somewhere lying alpha beta. Okay, remove that part from v2. Now they will become in orthogonal to each other. That is what it is happening here. That is what it is happening here. Getting idea?
Yes, sir. So after finding the inner product of v2 u1, we have to
Hmm.
multiply that with u1 or subtract.
Here this is inner product, and here the multiplied. This is a scalar multiplied with this vector.
Okay, okay. And after and the whole part I have to subtract with v2.
From v2, this whole the normal form here, the normal one given as here.
Okay, so first I'll find v2 u1 and then multiply it with u1 and then the whole part I'll subtract it with v2.
From v2,
Okay.
once you do that, so see, so what is the main idea? No, whenever you are doing this all, this is not a normal, so not a in a unit form, unit vector. As here, see that this is, this v1 is not unit vector. I just divided by now. So here as also you, whatever you are obtaining, this is not in unit vector. So to find the u3, okay, to find the u3, first make it this as a in the unit form, unit vector. So that's why if you see, then sir is writing u prime, which is nothing but u upon divided by the norm. And now the work will be done here. See that, the next formula, see the same thing is happening also. You will write here v3, okay, and what you will subtract, this part you will write the same, but here is from v3 remove whatever lying in. So see, let me write the formula first. V3 u1 and outside u1 outside v1, and also subtract inner product between v3 and u. So here is unit part, okay, just unit part you will write here. So either you can update in program, or maybe if you are writing the prime also, so try to write prime, because this don't match, don't mess up with the notation. Okay, so here is u prime, and then outside u prime. So what is happening here, from suppose here is alpha beta is there, okay, and here is something from here you have removed alpha beta, okay, alpha beta you have removed, but here also it will contain alpha beta something. So what you will do, you will remove from this part also, you will remove from here this part also, and from here that part, maybe c is here, c will contain here also, so that part also remove. Means what is happening, you are removing this part from this v3, you are one by one you are removing. That's way to remember also. So you are removing that part which is lying actually in v3. From v3 you are removing those part which are lying v1 and v2. So that you are doing with the normalizing and unit vector, that is the pictorial form, that is the picture form idea, otherwise this is a formula. And that is how I remembered also. For me it's difficult to remember. I started thinking, okay, what we are doing, from that part we are removing whatever the lying part is there in v2 and v1. That is what it is happening.
Okay, got it, sir. So even the U1 is just the U1 prime, right?
Even yeah, so if you say, so here u1 prime is u1 itself, because it's already written as well. So even you can prime is from starting prime you can write, and the next is like this, or maybe u1 is u1 prime is just u1 and the next head. So by this way you can do, first find the vector, divide with the norm. And now in the head operation do like that.
Okay.
Okay.
And sir, there
And
was one more this concept of normalization. We have to perform the normalization every time.
uh, in the projection we need it only generally.
So if we are asked to find the uh, Gram-Schmidt normalization, then ortho normalization something. So we have to perform that as well.
Well, while I was talking about this one, you were there, right? When
No,
I
sir.
was,
No, no,
huh?
no, I was not.
You missed that. Okay, so actually, why we needed, or when we needed this, while doing the projection, we needed such thing. Otherwise, no. Could you repeat once your question? I'm missing one word I want to say, but I forgot. I want
Uh,
what?
do do we
Huh?
have to perform the normalization, or uh, if we are asked to find the solve it through the Gram-Schmidt ortho normalization, then
Huh.
do we have to find uh, perform
Yes.
the that thing as well? That is
So
to
no.
find U1 and then normalization of U1.
No, so it's depend on, each. See, I when I was trying to solve this problem, now I again got. So when I was trying to solve this problem, I found these two vector and started Gram-Smith. But if you are lucky, if you are not lucky, if you do more practice, even I also am not getting. I just missed that. There, if you would do more practice, no, without doing so suppose for example, I am telling you, suppose I want to find, see, this is a two-dimensional vector, right? Sorry, subspace.
Yeah.
This is a two-dimensional subspace. Okay. So what are going to be the basis element here? One is way to find the basis element is just write this equation, okay, and bit solve. So y minus z it would be.
Yes, sir.
Okay. And now next step is assume y is equal to 0 and z is equal to 1. It will give x is equal to 1. So by this way, one vector you will get which is 1, 0, 1. Okay. And now next is substitute y is equal to 1. z is equal to 0, you will get x is equal to again 1. So this is going to be 1, and this is 1, and this is 0.
Yes.
Okay. So by these things tells you that these two are your basis element for this subspace. Okay, this is a basis. These two are basis element for this subspace. So, but I want a basis element such that these two are orthogonal. Here it is, these two are not orthogonal. If you multiply, means here you do the dot product, inner product, you will get 1 plus 0 plus 0, which is 1 you are getting. These two are not orthogonal. But I have to find, to do the projection, I have to find the orthonormal vectors here. So how I will get? So by doing this calculation, if you try to observe, you can get, or do the Gram-Smith. Means if you try to observe here, I have to, now I will try to find here. See, I want to find two orthonormal vectors. So either you can guess yourself while substituting. Okay. Otherwise, just do the Gram-Smith. So for example, suppose I took 101. The first one is I took 101. Now I have to find an orthonormal which is satisfy this one and orthonormal to this one. I have to find such a way. How I can get this? So assume that, okay, so assume that I have this vector A, B, C. Okay. Assume this is ABC. That vector is ABC. Okay. That means it will satisfy this one, correct?
Yes.
Means here A equal to
A is equals to
B
1.
minus
Yeah, B minus. Yeah.
means C. And also I am saying it is orthonormal to this one. Means what? Do the dot product. Means what? A,
The dot
if you
product,
do the dot,
yeah, it should equal to
just
0.
do the A plus C is equal to 0. Correct?
Yeah.
That means here you got two equation. One is the after substituting this one, and another one is A plus C is equal to 0. Means here A is equal to
Minus C.
minus C. Means what? If you, I will solve this system, easily can get. So it means that A is equal to minus C. That substitute here in the first equation. Minus C is equal to B minus C. Means here minus 2C. Okay. Okay. Sorry. Here minus C means here so B is equal to 0 I am getting here.
Yes.
B is equal to 0 I am getting. So that means our eigen, so and A is equal to minus C I have. So let's generate a vector using these three. Means here B is equal to 0. If I will substitute here minus 1. Sorry, C is equal to 1,
And
equal to 1. Then A is equal to
minus 1 then.
minus. Okay, so see, is this satisfying this equation first? Minus 1. Yeah, it is actually satisfying, correct?
It satisfies, sir, because the result we get is 0.
Result, yeah, we got from there. So just a second, let me make it charge in charge mode. So here see that. So I got, so one someone has asked, are you getting also correct? I last time I didn't solve. I solved with the Gram-Smith, but now I'm getting the different way also. So two, are you getting it?
Yes, sir. Yes.
So see that how it is. So one vector I have 0, 1, 0. Another vector is minus 1, 0, 1. Now check, these two are actually independent also, basis element also, and orthogonal also. Correct? If you multiply, if you dot product do, multiply means dot product, I means inner product, you will get 0. Correct?
Yeah.
And also satisfying this equation, both. this one also, and this one also, and these two are independent. So you got, means we got here two basis element and orthonormal, just divide with the norm. So orthogonal, just divide with the norm. Here is root 2, this one is also root 2. Now the simple way is, now do the projection here. I want to do projection 101 to this one, 101 I want to project. So do the separately as I wrote the formula. Okay, I hope now it is easy. So now your question, I am answering to your question, Vishal. So either you can do the Gram Smith, or just think as I did. No, just here this one. By this way also this will work. It's depend on your practice. This second type is, if you do more practice, or if you understand the concept of orthogonality, which I am using here. I use the orthogonality condition, right? Means also should satisfy equation, and also between the relation between these two vectors, and using that I found the equation, system of linear equation I solve, and I try to get a vector here.
Yes, sir.
So this is one way. Okay, Graham Smith usually give, but this is another way also.
Okay.
Okay, so this is how it is. And now I think in the solution, it is by that way. I think it is done by the Graham Smith. Where is that? It is done by Graham Smith process, but we don't want even that could be done by the different method also.
Yes, sir.
Okay. Any other doubt? I think others have left. Yes, Prithvi, you have any other doubt you have asked?
So yeah, so can you see activity 8.7?
8.7.
I think answer is given both the question. I think wrong. I say.
Okay. Self-adjoint operator, suppose, okay, still it is not written. This and this are two eigenvectors of T. Which of the following can be possible candidate for the third eigenvector? Three distinct uh, eigenvalues. Okay, self-adjoint operator it is. So self-adjoint means the eigenvectors are going to be orthogonal, correct? That is the because if the linear transformation is not given, that means eigenvectors are going to be orthogonal.
Yes.
So means the third eigenvector, which one is going to be the third eigenvector? Means it is going to be orthogonal to whatever the option is going to be correct here. That is going to be orthogonal to rest these two.
Mhm. I
So
think,
here two answer is given, no? But it should be only one. It
but
is
I think
not.
answer is CD, I guess. But it is given AB.
Okay, this is okay. I and this is I plus I, and this is 2. Yes, this is going to be, yeah. This is going to be 1 1 2, and this is minor. Yeah, this is C and D. This is one. Okay, this is one wrong. Yes. Okay. Yeah, this is the wrong thing. Okay,
And
and here also
question
this.
number two. Yeah, I
Yeah,
think I
I,
feel information is not given completely.
if the eigenvalue is corresponding to this is 5. Eigenvalue corresponding to U1 is 5. Then find the sum of the all eigenvalues of T. Okay.
If this is a self-adjoint operator, it means I guess eigenvalues are different. But I think is the way answer is given is the eigenvalues are all are same. That's why it's 15.
This is the PDF format of that activity is given, but it should be updated there. But I have to check. Okay, this answer is wrong. Okay, and this is here. Let T be a self-adjoint operator. This is the eigenvalue. Sorry, eigenvector. Okay. If the eigenvalues corresponding to U1 is 5, then find the sum of the all eigenvalues of T. Okay, suppose even this, and this are eigenvectors of T. This 5, then, and the sum of the eigenvalues. Some information is missing here. Okay. Uh, uh, 111. This is, I think, the idea of the self-adjoint operator. What are the eigenvectors are orthogonal? So here it is 1 minus 1. Okay, see it. This is the main thing here. What is happening here? See the it is saying the eigenvectors of T. Is this all eigenvectors are orthogonal? Is this orthogonal?
Mm, no, sir.
No, right? This one is also not. And when
Yes.
the self eigenvector are orthogonal for a self-adjoint operator, that is the idea here. Okay. Then what is the if the eigenvectors are not orthogonal, that means what for the self-adjoint operator? Okay, my question is if the
No,
eigen
no, I don't think so. It's self-adjoint.
sorry,
What you asking, sir?
I'm asking if the eigenvectors are not orthogonal, okay, for a
Okay.
self-adjoint operator, okay, not for any general operator, self-adjoint operator. If
Okay.
eigenvectors are not orthogonal, what it means for the eigenvalue?
Eigenvalues are same.
Eigenvalues are going to be same.
Okay.
That is the
Yeah.
condition. If eigenvalues are different, then eigenvectors are going to be orthogonal.
Okay.
But here, eigenvectors are not orthogonal. They are just independent but not orthogonal. In that case, the eigenvalues are going to be same.
Okay.
This is not true for any general operator. This is true for only self-adjoint operator.
Okay.
So that means for all three eigenvalues here, actually they are independent but not orthogonal.
Yeah.
So that means here the all eigenvalues for all three eigenvalues, sorry, all three eigenvectors, eigenvalues going to be same, means 5, 5,
Yeah.
5. So
Mm.
that means when
Okay.
we will add them all, it will be 15.
Okay.
I will check this first one, yeah, but this is the correct one. This is the
Okay, sir.
second part is correct. Okay. Okay. Any other doubt? Okay. So so uh, the probably by tomorrow the mock will be released, and the revision session is surely on Friday. I will I will give a post on GSpace, and also you'll get a notification on the portal itself.
Okay, sir.
Yes. Uh,
If possible, sir, please bring some extra question in the revision session also.
yes, sir.
Revision. Okay.
And sir, I wanted to ask you, hmm, can
Mhm.
you please give the topics which are considered to be important for the quiz?
Important. No? So convolution is sure, okay? So one question is from convolution. So that is one part. That is one. And this diagonalization surely, okay? This diagonalization. And diagonalization of self-adjoint is I will suggest you. If not, then at least diagonalization should be you should to know. Okay. And use of the diagonalization means why we are doing means here maybe question would be matrix would be given. Okay. He may ask that okay the diagonalization p d p inverse okay is this form. What is your d and what is your p? Okay, this could be, and maybe ask that what is a power 8 or maybe a power 100
Yes,
means
sir.
what.
This is a bit challenging for me
Mm-hmm.
to find powers of matrix.
So challenging, it is a simple, no? It is a simple. If you suppose, I suppose you are able to write in this form. Suppose your matrix A is written in this form. Okay.
Hmm.
So are you able to calculate this one?
No,
Is
sir.
it easy?
No, sir. Actually, I haven't reached till a week 8 yet.
Okay, you didn't read. Okay, but no issues. It is easy, no? It is just way to find the eigenvalues and eigenvector. This is the next step, easy one. Okay. Once you know this, the power matrix is if you do A square means what? What you're doing? P D P inverse. Again P D P inverse. That is what you are doing, bro. No?
Yes, to find the square.
Means square. So to find a square. So this is P D P inverse. Again P and then P D P inverse. See this P and P will be identity
Yes.
and this D will be
S-
at one place. So this
Yeah.
P D D P inverse means P D square P inverse. Similarly, if you do A power n, it will be just P D power n P inverse.
Mm.
That is what it is happening. So if you do A power 100, it is asked, just do this one and P inverse is going to be same, multiply them and answer the option. That is what is. It is the easier one. Okay. So here, I maybe the question we will this type of question would be asked in the step form means first find what is t, then what is p, and then the power. So three question depend on one problem, depend on one context.
Three problems from one context.
Yeah. So it could be. So yeah, from my side, I will suggest surely because I'm suggesting you to maybe this part is important. Okay, so this diagonalization is important, convolution is one important, and four fundamental is one important.
Four.
This weekend is a bit important week you can think for quiz 2 because many important topics are four fundamental spaces.
Okay.
Means here four fundamental is mostly just try to remember your null space and left null space at least.
Okay.
And from week 7, this least square I will suggest you.
Least square.
Uh,
Okay.
Least square solution. This is a easy topic. Easy means here this is a simple one. What is the way? Okay. Suppose somebody is asked what is the least square for this system. Okay, this system. So what you will do? Just find the A transpose. Let's say this is B.
Okay.
Okay, and then finally the solution of x of least square is going to be what? A transpose means B time. This will be multiplied a b time b something is there. This is just a formula. Okay, this is just a formula. This time I'm just forgetting here,
Okay.
but this is very simple. Okay, this is very simple, just need to do multiplication and multiply. It will be also asked in the step. Okay, if it is asked step means one option, one problem would be find the a transpose, then next is find the solution of it. It's
Same,
okay.
same like those a power question.
Yes. Yeah, so probably if it is there, it would be asked in the step so that if you are missing something, at least you were able to get some part up, some
Okay.
marks.
Okay. Okay, this is
So
fine.
this is list squares important. Try to see it at least.
Yes, sir.
And
Gram-Smith orthonormalization.
Gram Smith is just a process. So you anyhow you have to do the
Go through.
practice on here.
Okay.
It will be work on your back end
Okay.
means while doing the problem. So it will help in your back end, but not in the front. It would be asked means it will never maybe very less chance to come that which vectors are orthonormal. So
Okay.
means you don't do the Gram Smith. Just try to neglect the option. Try to multiply the vectors and which one is actually giving the zero. That is going to be orthonormal.
Okay, sir.
So without the Gram Smith will work in your back end, but not in front.
Okay.
So
Nothing else from week 7 then, sir?
week
Only
seven is
squares you have mentioned.
in week seven is this list is important,
Yeah.
and that's all. Maybe inner product. That's all. No? Because these all properties will be work in your backend. This front type question is
Not.
means here. Direct question maybe not from here,
Okay, sir. Understood.
but list is one important. And yeah, this matrix multiplication, matrix representation of a linear transformation is important. And this eigenvalues, eigenvectors is important to find which one is eigenvalue, which one is eigenvector. This could be.
Eigenvalues and vectors.
Hmm. And from 5, yeah, range null space, this part.
Range null space and okay of linear transformation.
Yes, maybe the dimension. Already these words we have seen from week 1 to 4. So dimension maybe asked, maybe basis element maybe asked. But this null space is an important maybe asked find the null space of the linear transformation.
Null space of linear transformation. Yeah.
So these are the topics probably will covered in the question.
So the
Because
main weightage is from week 8 only, sir.
so,
Sorry.
sorry, till week 8 would be only
Yeah.
from
So the main weightage is in week 8 only. Many problems.
actually week 8 uses more concept from week 1 to 8 even. Sorry, 4 to 8, 5 to 8. So
Okay.
not only on this, because if you want to do problem on week 8, you have to understand 5, 6, 7, 8, because 5 is needed. You should to know what is a basis and how to find a basis of a vector space.
Yeah.
And then 7 needed a Gram Smith also. If you know just now you said a one another trick, otherwise you have to know the Gram Smith at least.
Okay.
And week 6 uses
It is just multiplication of linear.
diagonalization. Sorry, week 6 is diagonalization. That is also needed to know the eigenvalues, eigenvectors.
Yeah.
So many concept are will be in the back end, not in the front. But yes, if you do the practice on those topics, that would more help.
Okay, sir. Okay. Okay. I'll try to solve those. I'll try to finish week 8 first, and then those for questions which are phased out, I'll probably ping you or personally message you on GSpace then.
Okay, yes, fine. That's
Okay, sir. Then that's it from my side.
okay. Okay, Prithvi, thanks. Thanks, Vishal.
Yes, sir.
Thank you, sir.
All of you joined. That's good for me to people are active at least. Student actually focusing on quiz too.
I,
That is
actually, the problem is, sir, because this becomes too late for other students also. 8 to 10 is normally their family time or dinner time. That's the problem. After 9, people started leaving.
okay. So maybe what timing would be good?
Um,
7? From
late,
7?
late afternoon. That is probably Oh,
But after noon, and then many people will say my work is there.
Yeah, many colleges student
They
who go
just
in college.
5 6 around that time, sir.
5 6 is even that is even working hour. So maybe I can reduce even 7, because you are saying for you too it is good, but others, many people will say, because we have already seen from DS data science already. So generally I can reduce even from 6 or 7. So we can start from 6 and 7.
So can you try to get a poll on GSpace then, where people can give their opinion when they are free. You can just say that we have less number of participants, so when should I um take up the lecture or session?
Okay, maybe I will be message that what is going to be the suitable time. Maybe if
Yeah.
we want to reduce or earlier, make it earlier from 6 or 7. Maybe I will ask in the G space, that would be good or maybe more convenient.
Yeah, yes, sir. So that we can have more number of participants also.
Yes. Okay. Thanks. Thanks to both of you. Thanks for others also have joined it. We'll see the next on,
Yes.
Friday. Friday will probably Srikant may take, so he may discuss.
Okay, sir. So can you tell? You were supposed to give the extra questions, right?
The mock we'll see. So mock is one thing, but yeah, I will try to say him to take some extra question. Even he can directly, if you ask a new type, no, so he can that instantly he can give. He is that much capable to give new questions. So if you just say that time itself, he can create and give you.
Okay, sir.
I will say him to take it new questions, but he is very capable to even
Okay.
instantly keep the questions.
Yeah. Okay, sir. Okay, sir.
Okay.
Okay. Thank you then.
Yeah. Thanks both of you. Good night. Bye bye.
Good night. Good night, sir.
Bye. Good night, sir.